When I place this block, it's gonna blow your mind. Hi guys, and welcome, Knemon here. Today we have our 5th episode of our Scarpet programming series where I'll show really cool stuff you can do with Scarpet programming language inside your game. What is interesting, during Minecon, the Minecraft Bedrock team was showing a start of their ventures into scripting. Well, and we've shown in the previous episode, I think, a little bit cooler way of messing up with your world. Don't you think so? Now, the coolness of the Vein Miner and the Holy Hand grenades would be really hard to beat with inventory management, but some of the programs I'll show today could solve some real pain points you might have with the inventory management in this game, and I'll show you how to do it. First would be a simple app that was actually requested by none other than famous XCOM. One gripe he wanted to be solved is a situation where you mine blocks. The blocks will not immediately go to your inventory if they can. By enabling this app, as we can see, all the items we will mine from now on ends up in our pockets. Now there are two variants to this, which I'll demonstrate with a salmon and a stick. So if you mine a block with anything else, that would drop their loot as usual on the ground. But if you break them with a stick, they will go directly into my inventory. So let's turn off F5 and hitboxes. So what happens is that for all the loot that spawns from the block we mine, we teleport them to the player and allow them to be picked up right away. This would probably also be a solution if you would have built a vanilla data pack with commands, since all the things here are available as commands as well, like selecting entities and teleporting them to the player. The second approach would be the salmon one, which is that for all the spawned loot, if there's a space in player inventory, just insert it directly. And this you would probably have really hard time doing as a data pack. Also the items, they disappear instantly. As you can see, they are not moved to the player, so if the space in our inventory runs out, the items will just drop on the ground as they would normally do. Cool stuff, so now let's jump quickly into the code. I'll be skimming over some parts of the code later, which you can check out on your own, but focus on a few interesting aspects and constructs that might be interesting. But first, I've seen a few comments asking what the Scarpet language is all about and how to start with it, so I'd like to briefly touch on these two aspects with this simple example. Scarpet language is very simplistic. It contains of numbers, like these ones, or this one, and this is also a number. They can also be floating points, hex base, etc. Second type of constants are strings, which are just sequences of characters encased in single quotes, like here. We also have tail line comments, which are removed when the program runs, so this is just for us to remember what each thing does. And also we have identifiers, which are names of functions and variables and a few other bits. Apart from that, Scarpet has also operators, so for example this is the equality operator, this is the container access operator, and this is for example a matching operator, which for all intent and purpose are just variants of functions which consist of identifier like this one, or this one, and the list of arguments separated by commas. They are pretty much the same, and that's pretty much it. This is like, for example, a define function operator. Even a semicolon is just an operator saying, in this case, to first execute the first if function and then execute the other one, meaning that there is no semicolon at the end of the second if because it doesn't separate anything else. So the entire program is just one big mathematical function which just happens to do some things for us as a side effect. So in case you need some resources how to start with Scarpet, I'd recommend a very deep and thorough documentation that we have with examples and all the built-in functions and constructs of Scarpet. As well as you can check the Scarpet programming repo, which have a few examples of programs doing various things. On all the links, including links to the programs I'm showing here today, you can find as usual in the description. So what I like to do when I'm writing a program is to have the game running on the side just to test interactively some of the constructs I type in. For example, here we have a test to check if a player is holding a stick, and if you go to the documentation we can see that gets all this stuff out of the way and just search. The holds returns triple of short name, stack count, and NBT of a held item slot. Available options are main hand, offhand, head, chest, legs, feet. If slot is not specified, the default is the main hand. And if we go to the beginning of this section, you can see that the matching operator is a shorthand for the query function, so either should work. So if we go to the game and type script run p is a variable that points to the current player. If we query it with holds, we get this. It's a list. As you can see, the first element is its name. We can get it via the get or element access operator. This way we can compare it to the constant stick and do it this way. So to get to our auto pickup, for the demo I tracked whether we broke the block with a stick or a carrot and called the move functions for that. I could call them directly, but in general, when these events happen, we might be during some step of this event's happening. In this case, for example, for a broken block, we get the original block as we broke as the parameter, but the block in the world is already gone at this point and turned into air, which might be useful in some cases. But one thing that happens much later is generating the loot. So in order to grab that loot or item entities, we need to defer our call to at least the end of that tick, which we can do by scheduling our call with 0 delay. This will make so that our handler function for the action we subscribe to will be executed at the end of the tick, so the loot will always be there. Now in this case we have this massive entity selector here, which selects items in the block space of the block we just broke, and for each of those we teleport them to the player and sets its pickup delay to 0, so player can pick up them immediately. So in general that would be the standard way of doing it, that like you would for example do with data packs, but we can do better. This filter function here on the age of 10 is just to make sure that we only target freshly spawned loot, which spawns with a pickup delay of 10 ticks exactly. Otherwise, if we can skip this check and this filter call in general. What is interesting, for example, is that if we break a chest, its content spawns with 0 delay, but the chest itself, it has an irregular 10-tick delay as all the broken items, so that would not move the content of the chest for us, but just the chest. But if we remove this filter call, it will move everything to the player. We start the same by iterating over each item, but then instead we check existing filled slots in the inventory that hold that item to check whether they can merge with the current one that we have, and if that's possible, just add them to their stack. And if this doesn't happen, you just need to find the first empty slot and insert it there. For the player inventory, first 9 slots is this hotbar, next 27 is this main inventory, then we have 4 for armor and then 1 for the offhand. So we'll only insert it into the regular inventory in this case, since we limit it to 36. Since loops in general don't have any exit mechanism like you would know from Java, like continue or break, I'm making here my own continue by wrapping the code with the try function, and on the accept clause, if we are here, it means that we have inserted the item into the inventory successfully. We just need to update the entity by removing it. And that's it. As an effect, we get a clean ways of mining blocks and skipping falling them on the ground while keeping them where they should spawn originally in case our inventory runs out. Another application that's really near and dear to any player really is when you run out of blocks, rockets, ender pearls, food, what have you. You just need to stop, take it out of the shulker box, place it, grab one, break it, pick it up. It's kinda annoying. So what if each inventory slot in the hotbar could refill automatically from the shulker box right above it? You could have it either refill your rockets or ender pearls, but also maybe organize the items better in the box so we can just keep placing the blocks, not thinking about swapping them. Might be not that useful in this particular case because of the limited capacity of the shulker box, but I think it's more applicable, for example, to build a rail with a powered rail every third of a stack of regular rails. So with a shulker box like this one, we can just keep placing, and blocks should be supplied to us in order we need them. For that, whenever we run out of items, we would like to take whatever is in the next item in the first slot of the shulkerbox inventory. So let's check how it's made. So this one is a very short app. The key is we want to track all the events that may cause a player to lose an item and being left with an empty hotbar slot. So you want to bind to as many scenarios as possible. So play using an item would apply to rockets, ender pearls. Right clicking on a block might be for fire charges, placing blocks. Breaking a block if our pickups, for example, runs out, breaks. Interacting with entity, it's for example for the newly introduced golem repair behavior. Releasing an item is for example throwing a trident. Finishing using an item is a server-side event, for example when we finish eating food. And also attacking entity, for example our weapon breaks. In some of these cases, as I said, not all of them, the item may still be in the inventory where that event happens, so like before we want to defer our check to the end of the tick. In this case, we make sure that player has nothing in its hotbar slot, has a shulkerbox in the slot directly above it, so plus 27 on the index in the inventory, and it has some items inside of it. In this case, we give the player that first item, as well as we delete from the shulkerbox that tag as well, not forgetting about writing everything back up to the inventory. Quite straightforward, and that's pretty much it. Another variant of this function would be to try to restock any item that we ran out of from the hotbar with whatever we have in the inventory, as long as it's the same type of item. This would mean that we are stuck to one type of item in one hotbar slot until we manually move them around, but for all intended and purpose that makes actually a lot of sense. Since we'll be restocking from anywhere really, we could code in fetching items directly from the inventory, as well as from all the random shulker boxes, trying loose items first, and then items in shulker boxes next. Obviously, our logic could be as complex as we would want, replacing, for example, empty water bottles after drinking a potion with a potion, or maybe empty buckets of whatever liquid we had before. But for now, let's focus on a simple perishable item. So when we run out of the slots in the inventory, we'll just replace them. Let's quickly look at the code. As previously, we want to hook up to as many player events as we could that can cause items to disappear. This time we need to indicate a hand, because we can also restock the offhand as well. With things like breaking blocks, it's only the main hand that can be affected by the lack of items, while with other actions can be performed from the offhand as well. And again, we'll defer the refilling of the hotbar slot to the end of the tick, just to make sure that all the things would finish in the game to cause our hotbar slot to empty. And important is to pass our previous item we had before while performing this action. Thankfully, events either send us the stacks as arguments, or we can just pull them off of the inventory when the actual event happens for posterity. The replacement slot would be either 40 for the offhand and whatever is in the active slot for the main hand. Refilling the item is a little bit different. This time we won't be using inventory find function, because it always scans inventory from the beginning, and in this case we want to scan it from the end, grabbing from the hotbar slots if really necessary. First we search for regular items of the same type, and if we don't find anything, we follow with searching in the shulker boxes. Couple things to note: here I am requesting for all the items in the shulker box inventory at once with one call. So I can get nothing if there is nothing in the shulker box. I can get a single NBT if there was just one item, or a list. So with a singleton, I need to convert it to the list myself. One annoyance to working with NBT queries in general in vanilla. Also, item names or IDs inside shulker NBTs are prepended with Minecraft colon prefix, while Scarpet trims them down for simplicity. So to find a match, we just need to add that little bit to the name. And that would be it. A very, very handy app that allows to complain a little bit less about the inventory problems we currently have. Another application from Modded that I find just really convenient is the ability to set up your storage in a way that if you have a bunch of garbage items in your inventory that you don't need, you can just sneak right click on the storage controller and whatever they use, and all the items that can find their way into the storage will be gone and placed in the storage. Conversely, if you have some unfinished stacks in your inventory, sneak left click on a chest would just refill your inventory as much as possible from the storage. I'm not sure about the second behavior, I've seen it modded, but both are definitely very convenient. In order not to interfere with the vanilla block placing behavior, I limited it to the empty hand, but I guess it's just a program, so you can change it to whatever you see fit. Obviously, to handle that, we need to know which items are allocated to which slots in the storage. So for that, we'd require a player to leave at least one item in each slot, indicating their preferred item allocations, which is exactly the same behavior that is used in my favorite type of storage systems, the multi-item sorters. Obviously, in our case, we don't need any of our sorting system in the back, since items will make their way automatically into all the available slots. So let's see how this all can be done. In this case, we have a behavior on right-clicking and left-clicking a block, so we need to handle them both separately. In both cases, you want the player to be sneaking and had nothing in their hand, and that there should be some form of an inventory where they clicked. So for that, we need to find the storage by traversing through all the connected containers, and then for each item in the inventory, we either insert them into the storage or attempt to fill up the stack from the storage. To detect the storage, we'll be traversing in breadth the first search style, so going to the closest containers first and just gradually adding new ones to the collection, either until we reach all the touching inventories, or if we reach the hard limit, which in this case is 10,000 chests, which is quite a bit. Couple notes here that might be a concern for you. So we'll be traversing all sorts of containers except for these three guys. The reason is that they might be some part of the redstone circuitry, and we probably don't want to touch content of these at all. Also, the result of searching for the storage is a map of all the storage nodes, which will then pass for each inventory item. And passing arguments in Scarpet is done currently via copy, but it's a shallow copy, meaning that if we didn't pass that potentially large storage as a singleton list, that would copy all the keys and values unnecessarily for each player inventory slot, which might be a little inefficient. Passing this as a part of a list, the list gets copied, but the actual storage map is passed unchanged. So it's a little insider efficiency trick right here. In terms of inserting and retrieving of the items, is done in a very similar way as before. I won't be going into too much details, but we are using here inventory find call, looking for all the loose items, so we are not looking into shulker boxes in this case, but unlike previously, we'll be filling up all the stacks to full as many times as necessary to fill up to whatever 64 or 16 we have for that item. We also add a little particle just to mark which storage container was affected, as well as making sure that at least there's one item left in the storage in the retrieval mode, and that's pretty much it. The last app I wanted to show is pretty much the same thing, but in the form of a proper mod, mimicking the functionality of storage drawers mod. In this case, what we need to interact with our storage is a storage controller block. We could just use a renamed shulkerboxes called controllers, and that's how we'll be identifying them. All the chests and other containers attached to it will form a storage grid with slots allocated for items in the form of unfilled stacks as before, and all the empty spots will just remain unallocated for the future expansions. To feed the items into the storage, we can either right click on the inventory, but we can also pipe items into the controller, which they could then be deposited to the storage in some intervals. To retrieve the items, we will power it. As you can see, our particle score changed to red, and now the controller is in the retrieval mode. Now, shift right click or shift left click on the controller will refill our inventory instead, and also placing a single item in the controller inventory will make it refill them from the inventory at some intervals as well. Now, we don't want to do that often unless there's player interaction, because with super large inventories and large number of controllers, we may notice some lag it would cause, which is still way below the lag vanilla storage systems would cause from all the hoppers and items piping contents through. So that's not a big deal. Also, we want to be consistent, meaning that if we stop the server, stop the game, leave the area, all the controllers should keep running when we visit them back again. And for that, we'll be using app data, which is the only way Scarpet apps have to store consistently their state between game restarts. And for that, we just need to remember where are these controllers for each dimension and keep their positions in a stored app state, which is separate from all the world game files, and we'll just update them as needed, which is actually might work roughly the same way as we know from the built-in point of interest system from vanilla. On the upside, this means that our storage drawers app will function independently from the world data and potentially other Scarpet apps as well, which is swell. But on the downside, we need to write some extra administrative code to keep track of all the controller network, which is not a big deal. We also have a very handy command tool that will tell us about all the controllers the apps keep track of, regardless if they're loaded or not. So you can see we have even one storage here in the nether as well. As well as it will list the content of the closest controller with all the top items it has, total capacity, which should handle easily even large inventories, like in this case we have a massive storage of a couple thousand barrels, which is pretty much capable of storing 7 million items. And if we see those red ticks here are from the storage system updating the network every now and then, which is not that bad considering that the other spikes we can see here are just from vanilla villagers concerned about a couple thousand point of interest below the village. So in normal circumstances you would probably run the system with less than 5,000 chests anyways, so this actually does really well. So we can very easily store our items in this huge storage and retrieve them as well, and relatively low CPU cost. So I won't be going into too much details what this entire code does. I'll just mention what is important and unique. First of all, we have on top we have the app config definition that should return a map of app settings. In the editor, if you use some of the highlighting tools that are provided with Scarpet repository, if something turns orange, it means that's special. So now in Scarpet 1.5, if we have a Carpet settings scripts autoload set on startup, that would load all the Carpet apps from the world files, but to keep the app loaded, we just need to have that option added to the config as well. Also, all apps by default start with the player mode, which means that all the global variables and functions definitions are kept separately for each player, which is what you'd probably want for a custom tool or type of application, but in this case we'll be monitoring globally those controllers. So we want to run the app with our global mode, so this variable here is actually shared between all the players. You can read all about the modes in the documentation about details. So here we have our custom command that we have to display the storage info we have just seen, nothing special here. In terms of scanning the controller for total capacity, it's important to know that access and updating even deeper members of various containers, like in this case, can be visually greatly simplified with the use of colon operator and its L value properties rather than using a fully functional monster, which would be exactly this one, for example. Then we need to remember that we need to load app data from NBT when the app is loaded. In this case, we have our onStart function, and you can see that's not orange, so that's not an event that Scarpet is triggering, but we can just call it whenever we need it, just statically, right here. In this case, we need to load global controller positions from the previous session so we don't forget where we placed them. And this will be essentially our POI system for storage controllers. So every time we change something, we need to store all the controller's positions back into the persistent app data tag. Here we'll be storing for each dimension a list of points of all the controllers. So whatever we add a controller, remove the controller, we need to store that information on the disk. Since we want all controllers to function in all 3 dimensions, we need to either add handlers to all 3 dimensions tick events, or just go to the overworld one, but then we need to worry about calling our management task by switching the dimension for each for the proper one. Just this approach with 3 calls is a little bit more straightforward and costs roughly the same CPU money, which is pretty much nothing. So in this case, we'll be checking up the drawers every 100 ticks on average, and also display particles either red or green on all the loaded and active controllers, indicating if they are retrieving or storing the items. Also, the particles will help us determining if the controller is recognized by the system as well. In the check tick, so roughly every 100 ticks, we'll recalculate the storage of a random controller in this dimension in case the storage configuration changes. We might not actually need to call it every 5 seconds, to be honest, but every minute probably will still be viable. But for reasonable size storages, it all doesn't matter. Also, for all the loaded controllers, we need to schedule their transfer item operations. Now, and this is actually a really neat statement that checks if a block placed in the world has a custom name controller, because in vanilla it turns out that for compatibility reasons the custom names are stored in a string storing a packed another MBT tag inside of it, which looks really bad in real life, but to handle it in Scarpet is actually pretty neat. Here the rest of the code is pretty much the same. Here we transfer items to and from the controller. We just check if the position is powered or not and decide whether we are in retrieving or storing mode, and that's pretty much it. Oh, here we have a handy debug storage call that we can invoke in the game to visually inspect what's up. This one is actually limited to 1000 nodes, since we will be calling an armor stand here for each spot that will self-destruct in 200 ticks, as well as ton of particles. It's also a really nice example that you can actually define functions inside other functions as well, just to keep in mind that they will be visible from other functions as well, as all functions defined anywhere have global visibility inside your app. So as you can see in game, we can just, if you use that call, you can actually see where all the containers are actually connected and what are their distance to the main one. Pretty cool stuff. Now we need to handle player right-clicking on a block for 2 reasons. First is to detect with sneak click on the inventory to automatically sync player items as we had before. But also we need to monitor when we place other blocks for the new controllers, we can keep track of them. Right now placing blocks and right clicking on a block is handled in this just one event, but I can see that we would probably need to add a separate callbacks for placing blocks and activating blocks, and we'll probably be adding them in the future as well, but for now they're all handled in just that one event. Also, since we have a different behavior from when the controller is powered or not, we can have the same sneak left click behavior does exactly the same thing as sneak right click does. Or maybe we should only have the sneak left click for item manipulation? I don't know. You can be the judge, you can change it if you want. And the rest is pretty much a copy pasta from what we had before. Feel free to scrutinize the code that you see here and make changes to you as you see fit, but as I said, Let's tab over here with managing and of controller positions and what happens around special blocks that we define special. You can use as you want for your own mods as a template. Anyways, that would be it, guys. Quite a loaded episode, but oh, I am so excited about Scarpet development and how with persistent data storage you can actually write your own functional mods that may not be able to add new blocks to the game, but will be able to add special new functions to items, tools, entities and blocks that could only be possible previously with modding. In case of special items, like how they look visually, you can add them with data packs in resource packs. Having said that, that's all for today. I hope you enjoyed it, learned something interesting, and if you did, don't forget to leave me a like, subscribe if you are new, and if you just want to use these mods on apps as is, feel free to just download them from the links in the description, and if you want to change them, upgrade them, or just play around with Scarpet, feel free to check the links in the description for all the resources that you need to start it, and see you in the next one. Bye bye!